Hello again. We're back in business. We connected with the next speakers, so that's going to be fine. We're in the decade of ocean for sustainable development. Well, more than 70% of Earth's surface is covered by oceans, as you probably know, and they play a key part in shaping our weather and are driver of the global economy and the sustainable development. Well, 2021 until 2030 is a decade of ocean science and development, proclaimed by the United Nations to support efforts to reverse the cycle of decline in ocean health. Slogan of the United Nations is the science we need for the ocean we want. Sounds good. Decision makers rely increasingly on satellite data to create the conditions for a sustainable development of the oceans. Well, we have a poll again. I see not everybody can find the poll at the right moment, but well, we can keep on trying. Poll number 7, do you feel usually have enough resources to communicate about oceans and sea level rise? Is the answer yes or no? For the Netherlands, this is very interesting because it's a low-lying country. Half is low-lying country across the North Sea. And the deepest part of the country is 7 or 8 meters below sea level. So without the dikes, we would only have half the country left. And what's going to happen within 50 years is half of the western part has to move to the eastern part. That's very interesting. So what's happening in the ocean is very important in our near future, especially in the countries close to the ocean. We have three speakers. We have Jörg Schulz. You might have seen that he's from the ECMWF, but he's not. He's just from EUMETSAT, but he delivers to the ECMWF. We have also Thomas Laverne. We will speak to him later. And Paul Kounet. All three gentlemen, welcome. First, we go back to Jörg. He lives in Bonn in Germany. He likes the West German history. He's very happy when he's got happy people around him. Well, it's the same with me. I hate cranky people. He likes reading and traveling, and he's especially looking forward to the end of the pandemic. I can imagine. And well, I wanted to know where I can wake him up for in the middle of the night. And he said, I won't tell you. Na, 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 na. Okay, that's fine. That's fine as well. But what's interesting, once he was asked in a radio interview, what are you actually doing? And he explains that he was working at EUMETSAT. And then they agreed actually that it was a better job title for him. Being a satellite data archaeologist. Satellite data archaeologist. Well, that's very interesting because it's still a young business, but we use the satellite data for a very, very long time. Jörg, tell us about how satellite data support countries in creating improved conditions for the sustainable development of the ocean.
Yes, thank you, Helge. So I will do that. And just one word on the data archaeologists. So that came because in that interview, we were talking much about satellite data rescue from past data, which lies around in tapes and cellars. And we are very keen in bringing those data up to really analyze also kind of past climate. So I will bring up my presentation. So you will not see me anymore because I had some technical difficulties, but you will hopefully see my slides. And you should see them now.
Yes, we see your slides.
Okay, very good. So the title is How Satellite Data Support Countries in Creating Improved Conditions for Sustainable Development of the Ocean. And I had some co-authors on this from EUMETSAT, and they helped me a lot in getting the right slides in place here. So I will mostly talk about what satellites actually can do for this development and what data they bring, with a little focus on the sea level indeed. So, of course, let me start. Observations are super important, and some of you have seen this figure that appeared in Nature a couple of years ago. And this is even more important as we experience big changes and fast changes in our climate, and humanity needs to live with that in the future. And of course, we need to do a lot of these observations to monitor the climate change, or to really improve our understanding of that system, and also to do better prediction and projections of climate change. And this is very much indeed the same as with human beings being in a hospital. So you're really monitored, diagnosed. So you undergo the same treatment as we do with Earth. So it's very important for weather and climate. Okay, so when you just look at a couple of parameters that you can look at from space, I have here on the top right sea surface temperature, so that's just the temperature of the ocean skin, ocean color, so that's more biological feature that comes from all the stuff that swims around in the ocean, and then about sea level, sea ice, and I think Thomas will talk about a lot about sea ice, waves in the ocean, and also wind. And then you see these circles interconnecting what kind of applications you can serve with that. And that is not only weather forecasting and climate, but it's also a lot about environmental issues like pollutant transport, oil pollution, biological effects like algae blooms, what you can see in the colorful plot in the bottom, but also marine safety, renewable energy, and also on the right, you see things like aquaculture productivity. So with just measurement of a few parameters, you can have a tremendous impact on many different things that are affecting life on Earth. So EUMETSAT is very keen with weather, in the context of weather, and you have heard a lot about this in the morning. And I just make a depiction here of a BBC presenter. I think it's in the late 1960s or 1970s, so back to history. And with an actual weather picture from yesterday. So that is how we look at this and what data we deliver in real time. But on the other hand, at EUMETSAT, we also do very long time series, so exploiting our missions, but also missions from other agencies back to the beginning of the satellite era. And here you see just a picture that starts in the late 1970s, but there's even potential to go a little bit earlier with even more historic emissions, and that's where the data ecology comes from. So then, of course, the results of interpretations of these data go to several of these reports, like the European State of the Climate that's issued by the Copernicus Climate Change Service, or a more global report issued by WMO, but also scientific publications like State of the Climate, or assessment of climate changes by the IPCC that we'll hear about later on. And the Paris Agreement, of course, and its implementation is supported by all these observations. And the Paris Agreement, as you see in writing, is actually calling for these systematic observations. So we really support the implementation of the Paris Agreement in the UNFCCC, the United Nations Framework or Convention on Climate Change. So this is the big context. So what do we deliver? So we have really integrating and growing stream of EUMETSAT marine data products. And you see here NRT delivery, apart from the climate data records. You see here big streams where all flows together. And then we deliver this to services like, for example, the Copernicus Marine Service that adds value to the users. And the users are really benefiting from this extra service. And there will be a lot of contributions from the OCSAF. Thomas will talk about that. And you see here also on the left and writing a lot of new satellite programs that you have seen in the morning, like MEDIASAT third generation, EPS second generation, but also more Copernicus program satellites. And we also deliver data from so-called third parties, so from agencies and countries outside of Europe to our users to really make the best collective use of all these measurements for marine services. What is also important in this context is, of course, in particular, if you look in climate, that these missions are really long-term and being continued for a long time. So you see that, for example, the EUMETSAT Polar System second generation, so a classical program, lasts for about 20 years. And then below, you see there are more Copernicus missions coming up, and they will add also new mission capabilities like sea surface salinity. So that's really important to better understand ocean currents and deep water formation. So that's directly addressing things like the Gulf Stream in the North Atlantic, and that has profound effect on weather, but also on climate within Europe. So now I come to sea level, and just to put you in perspective from climate. So people have tried to reassess and analyze the sea level back 3,000 years, so with different methods, so ocean sediment investigations, and then you see the last almost 30 years being dominated by satellite measurements. And what you see on the very right is the sea level today compared to the sea level in the last 3,000 years. And you see really that what we see today, the current levels are really quite unusual. And this should really make us aware that there is a problem looming, and not only for low-lying countries like the Netherlands. So what is the impact if we would stop emitting carbon dioxide? And that one needs to be aware that some of the components in the climate system react very slowly. And the big ocean water body is one of those, but also glaciers and big things like ice sheets in Antarctica, they do not react super fast. And what you see on the right side here is a plot of different projections with scenario runs on what CO2 concentration we will have in the atmosphere. So they have different scales. So you see sea level change with a low CO2 concentration up to 1 meter change, up to 2 meters in the sea level in a medium scenario, and up to 5, 6, 7 meters in a high CO2 scenario. So what you also see, if you look just at the dark red bars, that even if we would stop or have very minor emissions, that the sea level rise will continue at the scale of a couple of 100 years. So it has no immediate effect, whatever we do now. But it's even more important that any decision that is taken now in negotiations around the Paris Agreement is very important and affect our lives for at least 10 to 100 generations of people coming. And of course, you can also say we need to observe for very long times to really understand what is going on with the evolution of the sea level. So just that you get this a very long time horizon that is beyond humans' imagination for some time. Okay, so now I come to one of our recent missions, and you have seen that in the morning a little bit by Paolo's talk. That was the Sentinel-6 launch in November, and you see the video from NASA on the launch, very successful. And the picture that you see here, the big picture, is just like that the Sentinel-6 microfilaric observations are not alone. So they come with similar instruments on other instruments, and you see these colorful orbits. And when they interject, you see that they both basically deliver the same answer. So they are all interoperable, and we can use them all together to support really global maps of sea level, as you see as a background here. And this picture here is from 4th December, so that's about 2 weeks after the launch. So there you can see how quickly one can actually utilize even new observations in that context. You have also seen the sea level change in the morning. So this is the last almost 30 years. The overall trend is about 3.22 millimeter per year from all these different emissions that we had since the early 1990s. And of course, we continue and also reprocess the data to really put all these different missions into a consistent time series. But apart from this global mean, we can of course also see things like climate phenomena that you have certainly heard about, like El Nino or La Niñas. And these two pictures show actually two El Nino events. And we all know that these are really affecting lives around the Pacific, but also beyond on the longer scales, even for people living in other parts of the Earth. So these things are systematically monitored, so we can really understand how often these features appear, how strong they are, and how they change with the changing climate. You can also connect, of course, climate and weather. And this is just an example that shows you sea level for a hurricane. This is a Hurricane Katrina. And I think in the morning there was a presentation by Tony McAnally from ECMWF about storms. And this is just showing how altimetry is actually contributing to that. So what you see here is the track of storm and with the dots. And each dot has a different color, which is representing a wind speed. So you see how the storm is amplifying. So when it gets to the very red circles, and the colorful map underneath is basically showing you how much heat is stored in the upper layers of the ocean. So you see when the storm moves over an area with a lot of heat, then it's really amplified in force, and it's then getting less strong when it hits land through all the friction on the land surface. So with having these ocean measurements, you can really help to predict better storms, of course. And of course, on long range, as we know that the hurricanes might also change a lot with the changing climate. So last year, I think we had one of the record seasons in Atlantic hurricanes. This is also contributing to the understanding of why this happens in relation to what the ocean is doing. So this is not only then surface, but the ocean heat content is already going into some layer in the ocean. Okay, the last example I have here is also weather. And this was a storm that basically came over the North Sea in 2013, and a nice weather map animation from KNMI. And then you see that we have had an overpass of an older instrument over the German Bight and going out over Norway. And on the right, you see some cuts along the track of the satellite. And you see that we can not only level sea level anomaly is measured, but also the wave height and the wind speed. So with this, of course, you can produce things like weather forecast and coastal measures for early warnings for these storms, but you can also contribute a lot to marine safety with this wave height forecast in the end. And of course, long term, if these storms change with climate change, it is very nice to have these measurements to inform adaptation measures along the coastlines. But also maybe contributing to a new design of ships that can cope with different wave spectra and wave height appearing on global oceans. So I think these are very useful measurements in terms of many, many different applications. So one last slide, and this is the space agency, of course, cannot do this all alone. And you see here a lot of colorful pictures, but there's a long value adding chain from the space agencies here on the right, like EUMETSAT and also ESA, of course, in Europe, through a lot of subject experts and researchers in universities, and then down to services that deliver the products to the stakeholders for the different sectors. So the collaboration across Europe has been developed a lot over the last decade. And I think this is a real asset for Europe that we have established that and work nicely together from the space agencies across all the other institutions that are contributing to this for all the marine applications. And finally, the take-home message is that the data that we make available are really essential for weather forecasting, but also for long-term analysis. So they really form scientific backbone of many of these international reports on climate, like published by WMO and IPCC, and inform decision makers on mitigation, but also adaptation strategies. Well, the next generation of satellites, so starting in 22, and you have seen a lot about new programs in the morning, will allow to improve position scope of the prediction models. And I allude a little bit to the data from Sentinel-6, and that ensure that our users can really benefit from continuous high quality set of altimeter data that started with the Topics Poseidon in 1992. And it's a long way from the measurement in space to suitable products. And this is really a requirement of a wide range of expertise and many institutions working together. And this is all for the benefits of our users. So with that, I thank you very much for your attention. I stop sharing and then you should see me again.
Well, we look. Yeah, I see you again. That's cool.
So at least that.
Well, even I was thinking the atmosphere is complex because what's happening in the north of the Netherlands might be different than in the south of the Netherlands, and we are a pretty small country. But even in ocean heights, sea level rise, it's so complex. It differs from year to year. It differs from north of the Netherlands of south of the Netherlands. And what you showed us is more I call it a resolution, where it's just one value. I need more precision data to communicate it to the audience, because how can I do this? How can I make it? Okay, well, I'll ask it differently. When will be the moment that we can zoom in a very close area and then see the little difference between 10 kilometers north or to the south?
Yeah, I think the moment is already there with the Sentinel-6 measurements. So I think these measurements have a much more higher horizontal resolution. So this allows really to getting much closer to the coastline. So the example that I showed you, that was from 2013 with a rather early instrument. So now you would see these latitudinal tracks, which much more detail, of course, and this should help to really take the right measures in the northern part of the Netherlands or the southern coast of the Netherlands. And so this is a significant increase in spatial resolution. So the new class of instruments is helping that. It is, of course, not really helping on the long-term history. No? So for the long time series, you cannot make the older measurements better necessarily, but so you need to keep both views, no? The classic view to get your long-term change, but you have also the high-resolution view that would support near-coastal applications.
And is the high resolution easy accessible for all of us, or do you have a special abonnement?
No, I think the Standard 6 data, they come in basically in two modes, high resolution products and low resolution products, and all will be accessible through the normal means how EUMETSAT is distributing data via its data store or in real time with different measures.
Okay, well, Jörg, you like happy people, and we should see a happy face on your picture. Your camera is still off, so that doesn't matter. We'd love to see you smile. Yes. That's good. Thank you so far for this part. Please, people, there is a poll, and within the poll we can try to figure out what your opinion is on several questions. I do see it's not for everybody easy to find. Probably you have three options: chat, question, and poll. You just have to click on poll, and then you see the question. And a question I would postpone with you is: do you usually communicate in September on the lowest sea ice area of the year and the impact it has on global warming, on climate change? Do you do that? Yes or no? Well, let me know in the poll. Then we go to the next person, Thomas Lavergne. Yeah, I practice on that name as well. It's a French senior scientist at the Norwegian Meteorological Institute. He's an expert in preparing long climate data records from satellite observations. And his focus is on polar sea ice, both in the Arctic and Antarctic. Officially, he's a research scientist. Thomas, share us some evolutionary trends on sea ice extent and explain how data records are helpful to a better understanding of the evolution of the Earth's sea ice cover. Tell us.
That's a program. Thank you for having me. And I'm really interested also in the answers from the poll, because that's really where I am. I do prepare data. I do try and explain what it means for climate change, but I really need the help of weather presenters and communicators in order to bring that message forward. And so in this presentation, I'm going to do a bit of background about sea ice and satellites and how we use them. But then I really would like to start the dialogue about how we do the presentation, how do we do the communication about those issues. So please enter the poll, and then please connect with me and let's interact, hopefully. So I start with a map of the world's ocean and ask you, well, you cannot interact with me, you cannot tell me where you are, but I ask you to think, where are you on the map? You're on land, probably, you're not in the oceans. So the oceans here are colored with their temperature. And so you have warmer waters, warmer ocean towards the equator, and then you get colder water towards the pole. But something is missing from this map, right? So what is missing? That's the sea ice. And here I added the sea ice now. So you see, it does cover quite an area at the poles. So sea ice is frozen seawater that forms at the surface of the polar oceans. And sea ice, it's a key element of the Earth's climate system. For example, in winter, it will act as a lid between the ocean and air. So the warm, relatively warm ocean and the very cold air, there is this lid of sea ice doing the insulation. And then in summer, the ice will reflect back the solar radiation back to space so that it doesn't hit the planet, for example. So at least those two roles are critical for the climate system. But sea ice is not only that. Sea ice is also an habitat and a breeding area for whole ecosystem. And here I just show a large animal, but you really have to think there is a whole food web and food chain that is relying on sea ice. So from the plankton to the algae, the fish, the birds, and then those big animals, and then ultimately the local communities. And then sea ice is also, it has been an issue for the navigation and the exploitation of resources in the Arctic. And here I have a picture of a ship traveling sea ice cover. So when we think of a ship traveling in the Arctic, we think of routes, right? So here that's the an illustration of two routes. If you want to go from that part of the world back to Europe, well, the traditional route is the red one going through the Indian Ocean and the Suez Canal and Mediterranean Sea. But then there is this idea, the opening of the blue route that goes through the Arctic. And then if you go through the Arctic, you need to navigate into the ice. And or you're waiting for the ice to open. And that's what I'm showing now. I'm doing a zoom on the Laptev Sea, that part of the Arctic Ocean. And I'm using my satellites to measure how much sea ice there is. And I give you the following map. So that map here, the graph here, it's for every month of the year. For year 2021 in red here, that's the area of sea ice there is in the Laptev Sea. And you see that the area already started to drop at the beginning of June. Now we are mid-June, and we are right now at a record low value for this region of the Arctic. And so this is like the start of the opening of the route for this year. And the previous record we registered or recorded, it was last year. So really each year, there is some variation from year to year, but it seems like currently or lately, it has been accelerating, and we have this opening of the Laptev Sea even earlier than other years. So how do we know? How can I tell you that there are 0.6 million square kilometers of sea ice in that region of the Arctic? Well, we use satellites. Really, satellites are our eyes on the polar regions. We can't, there's not enough people there. There's not enough people living there to do the monitoring of the weather and of the sea ice. So we really are using the satellites to do the monitoring. So we can't use the same satellites as so we can't use the geostationary satellites, for example, that you are used to watch on the television, for example. We have to use those polar orbiting satellites. And the one I show here is one that the Japanese Space Agency operates. So JAXA, here, the map. And if you look at this image, even if you're not an expert on sea ice satellites, then you can see where there is ice. You can see where there is ocean. So the ocean is darker, the ice is brighter in that image, but you also have the distinction between a young ice and an old ice. So all this we can tell from the satellites. And not only we can tell where the sea ice is, but we can also look at how it moves. So here it's an animation. I hope you see it. It's one image a day of the Arctic, and you will see that the ice is freezing, so it's growing in extent, but it's also moving around, and that's because it's pushed by wind and ocean currents, and it's moving around every day. And so satellites, they help us monitor how sea ice melts and freezes, but also how it moves around in the polar seas. So once we have the satellites today, well, we are lucky because we also have 40 or over 40 years satellite data to use. And then that's really the core of my work at the Norwegian Met Institute with my colleagues from the Danish Meteorological Institute for EUMETSAT, OSISAF, and the ESA Climate Change Initiative. We are working together to process this satellite data in the most advanced way so that we can tell how the sea ice in the Arctic and the Antarctic is doing, how it's evolving with the changing climate. And so here is a graph where we have 40 years of satellite sea ice data. And this is the total area of sea ice in the Arctic. And so you see, for example, in red, that's the area at the end of the summer in September. And you see that we are losing and losing and losing ice. So there is a negative trend. The ice cover in the Arctic is shrinking. So that was the first part, right? I told you what the sea ice is. I told you we're using satellites to measure the sea ice. But now I'd like to go a bit further. I'd like to think, how can we communicate about that? So how do we visualize the shrinking of the Arctic sea ice cover? And I showed that graph already. We have other graphs. That's another graph you could get from website, from the OCSAF website, for example, where we are showing every day a new value of the Arctic sea ice extent. And so you can see here that's an image from Monday, I think. So the ice has shrinked a bit more since then. But so you can see 2021, where we are now in the melting season. So the Arctic ice extent is decreasing, and you see the arrow for 2012, which is the year where we had the minimum sea ice extent in September. So really the question is, are we going to have a new record in September this year or not? And I can't answer the question now. But what I can show you now is this. This is my colleague John Smith, so a weather presenter at the Norwegian Met Institute, that last year took that curve and showed it on the TV weather forecast program and communicated for, what was it, 30 seconds, 40 seconds, about the shrinkage of the Arctic sea ice cover in the Arctic. And at that time, if you look carefully at the black curve on that image, you will see that there was a record low, and that's where we communicated about that. That went very fine. I think what also works well when communicating the shrinkage of Arctic sea ice extent is to show before and after maps. So here we show the map in 1980 and the map in 2020. And so that's very visual. The general public really sees how much more ocean there is in the Arctic and how much less sea ice there is. And then, in addition, here I was trying to jump on a meme on Twitter, and that went quite well. So this is about the visualization and the communication. And here another example. Here I'm trying to hide the science a bit. So I'm using Halloween theme, and I use the mouth of the pumpkin to show the reduction of the Arctic sea ice. That one didn't work that well, but we can try to be creative. But we are just scientists. I'm just a scientist, so I'm really looking forward to the discussion and to the interaction at this forum. How can we do better? How would you visualize this change in the area? Right. So. And then when you communicate, so there was a visual communication, fine, but now what message do you bring with that? So Arctic sea ice shrinks, so what will they ask? So sea ice, of course, I told it's important for the local communities, for the wildlife, for ship transit, all those we can introduce stories about the Arctic with that. It has a huge impact on the climate system, so we can talk about the albedo feedback, like if you have less ice in the Arctic, then you have more absorption by the ocean, and that leads to less ice. So there is this bad circle of consequences. We can talk about Arctic amplification. We know now that the Arctic warms 3 times faster than the global average. That's the recent AMAP report. So that's also a message to bring. Sea ice does not contribute to sea level rise. We talked about sea level rise with Jörg just before. Sea ice doesn't do a big contribution there. It's the land ice that does a contribution to sea level rise. There is this question, when will we get an Arctic Ocean free for sea ice in summer? Will it be by 2035? Will it be by 2050? And then I noted that several of our the people attending are from the southern hemisphere. So there in the southern ocean, the sea ice around Antarctica, there are no clear signal. There is a lot of year-to-year variability. So here there is another message to have and another communication to have. What I think I will take one last slide now about a positive message about sea ice, I would say, because sea ice has no tipping points. And so the consequence of that is that our choices matter. And I will try to explain now what I mean with that. So here I'm showing a time series plot from the IPCC report. So the IPCC report, the special report on the ocean and the cryosphere in the changing climate. And what we see here is the evolution of the Arctic sea ice extent, so how much sea ice area there is in the Arctic. And you see two curves, a blue curve and a red curve. So the blue curve is really if the world meets the Paris Agreement target, really cut future greenhouse gas emissions. And that's where we really can control and make a change and actually control the loss of sea ice in the Arctic. If we don't do anything, then we're going to lose a lot, or even in the end, all the sea ice extent in the summer because of the global warming. So to me, so of course that's dramatic that we can lose all the sea ice. But also, yes, we can do something about it because the future of Arctic sea ice depends heavily on our future greenhouse gas emissions. So for Arctic sea ice cover, our choices really matter. And I think that's, at least I try to use that as a positivity message when communicating about sea ice in the Arctic. So really we have this red pill and blue pill choice, and the red curve and the blue curve. For sea ice, it really works. And you can say that our choices matter. All right, take home messages. Sea ice is frozen seawater in the polar oceans, both in the Arctic and the Southern Oceans. And we use satellites to measure how sea ice freezes, melts, and moves around. Arctic sea ice shrinks dramatically because of climate change, but our choices matter. The research community, we have good data and we are eager to share it, but we are no communicators. So we need the help of this audience, and I hope that this forum can help here. And I hope you enjoyed my presentation, and I'm looking forward to your coverage of the Arctic sea ice. Thank you. Thank you.
Thomas, thank you. Well, I have seen the poll, and do you feel you have usually enough resources to communicate about oceans and sea level rise? 86% says no. And what about communication in September on the lowest sea ice area of the year? 74% says no. So that means there's a lot to win. And what I was wondering, there were three questions. The tipping point, it matters whether it's sea ice because it can grow again once it's disappeared. But with a tipping point, it's the same, right? If you're before the tipping point, it still matters what you do.
Yeah. So, I mean, there is debate in the scientific community. Really, can you call the Arctic sea ice a tipping point or not? What I want to convey here is that for the Arctic sea ice, it's really reacting very fast to our future emissions and to temperature. So if we have control in a way. If we manage to stop the emissions, if we manage to stabilize the temperature at the Paris Agreement, then we're going to save some summer sea ice. That's not the same as other part of the weather of the climate system, where maybe what we've done already conditions a lot what will happen, even if we would stop now.
Yeah. Well, the second part has to do with that. You were talking about the extent area, but you also have the thickness of the ice. Mm-hmm. And you can see it partly by 1 year ice or multiple year ice. But communication about the thickness of the ice and implications of that, how you deal with that?
Yeah. So to measure the thickness of the sea ice, we need other types of instruments than the one I'm using for the 40 years. So the fact is that we have the satellites, but we have a shorter time series, and they are more difficult to use. So until now, I think we are not there yet where we can easily communicate to the public with satellite data over CI thickness. But the scientific community is working for that. But then people are going on the field. I mean, scientists are going in the Arctic to measure the CI thickness. And for example, what happened with the mosaic drift last year was really wonderful, and in terms of gathering CI thickness data from the Arctic. And there they can communicate much better than we with the satellites about the fact that the Arctic sea ice is shrinking, and they do see that.
And my last question has to do with what you showed, that now already we're in a record low on the Lepov ice area. Is it possible, because it doesn't say anything about summertime, it's still too early, I guess. Yeah. Is it possible to put in a 1 month prognosis, 1 month prediction, how it will go?
Yeah, so definitely. I mean, this is a very exciting research area where people do forecast at 10 days or even 2 days, then 10 days, then a month, then the whole season. And so the scientific community and even some of the operational services are doing that. But until now, we haven't the same certainty, let's say, as for weather forecasting, for example. And so we don't really communicate a lot or very with a lot of certainty about the forecasts. So for sea ice,
but it might be interesting for our weather forecasters to show it on TV or in the media, like, okay, it's now record low, and the prediction with uncertainties for the next month is that it's going to be staying record low, or it's going to be back into the area of the last couple of years. It might be interesting to do so.
It might, and I mean, if people are interested, they can connect to me on Twitter, and I'm often sharing a shorter, like 10 days forecast. And then, for example, now there are 2 forecasts out, and one of them says there will be a record Arctic sea ice extent in the coming days, and the other doesn't say so. So we have this uncertainty, but it's fun to look at.
That's the same what we do with tropical cyclones and hurricanes. So we have a path where it can go. But I followed you on Twitter right away, so I'll keep an eye on you the next couple of days. Thank you, Thomas, so far. Then we go to Paul Cornet. He is head of strategy and communication and international relations of EUMETSAT. And everybody knows EUMETSAT is a European organization for the exploration of meteorological satellites. He started as an agricultural engineer, but now he supports the Director General of EUMETSAT and is interested in as well climate as in space with his Twitter profile. Paul, EUMETSAT was a key member in setting up this day. Well, what did you learn so far?
So far, I wanted to say a few words to conclude this session, which was really oriented around the use of satellite data and how it could contribute to the monitoring of the weather, the ocean, and the climate. And I think if there is one important message, and the reason why we wanted to be associated to the forum is really that Europe will deploy very innovative observation instruments in the years to come. You might have been told already that we will launch 10 new satellites in the next 10 years. And it is very important that these data are not staying among us, I would say, the people dealing with the science, but that these data are really made accessible to the widest possible community, and we need therefore to establish a relationship with you. So that was the main idea before the participation of EUMETSAT in this forum Meteo et Climat. We have seen several examples. Tony has spoken about the weather forecast and how it will evolve and how we will, as satellite data provider, have to adapt to continue to meet the requirement of the weather forecast. And at the end of the day, you will use a weather forecast on television. So this is, we are upstream in the chain, you are downstream, but we need to talk. We have spoken about the oceans, and we have also seen how on the longer term, these data are relevant for climate. So voilà, so I hope that we have raised some interest. We have put a focus on Africa today also, because Africa is one of the first new satellites that we launch will be above Africa. So we will observe Africa. So we want to make sure that our users in Africa benefits from these data, because the continent is clearly impacted. And again, my message is to say we did not come as a one shot. We really want to establish a long-term relationship with you. Every year we'll come with new things, so I hope you will still be there. It is a pity that we have not been able to welcome you in Darmstadt, but it's still an idea that we have somewhere in our mind. And when discussing with Christian what the next step will be, I'm sure that hosting you in Darmstadt one of these next years is still a project that we have in mind, because it's always important to see things. We have been virtually sharing ideas, sharing image, but coming to Darmstadt, you will really see how we talk to the satellite, how we get the data from the satellite, how we send the data to the user. So it's much more lively. So it's one of the objectives that we have in mind. So from our perspective, I think this has been a real success so far. I hope that you can share this impression with us. And yeah, with this, I'll give you the floor back, Helga. And
well, is there anything that surprised you today? Because, well, you know everything about EUMETSAT, but now you learn the people who are watching and what's happening on social media and stuff. Is there anything that surprised you, what you learned?
No, yes, of course. The very beginning of the meeting was very surprising when we did not manage to put our video online. So that was the main surprise. No, what is very important is that we realized through an interaction with you and through this type of workshop that the traditional way that we have to communicate on what we do, we realize that normally we as an organization like EUMETSAT, we address very specialized users. And we need to go much beyond than this type of users. There are many more people who could be interested in what we do. And there we need to be a bit imaginative and a bit creative. So you mentioned that the presence on the social media, the type of things that we are doing today are very, very important if we want to reach this broader community. And what I've learned also is that we need to be able to talk about what we do in a much simpler term, because yes, we are all specialists in our area, but if we want to convey a message to a broader community, we need to be much more simple, and this is where we need to learn from you. So,
well, maybe we of course, I want to see you next year in Darmstadt. But maybe during the year, before it's 1 year ahead, maybe once every 3 months, EUMETSAT can give a kind of webinar and show what they're doing and giving tips and tricks, maybe?
No, these are typically, but we've learned a lot over the last 18 months. So I think we are becoming specialists on doing online events. We also know that people start being fed up with online events. And a positive message of today's meeting is that the attendance during the different session was really high and was quite constant. So I hope we have triggered some interest. But yes, of course, we would always be ready to do some update, and true that we might not have to wait for another year before being again with you.
I already see in the chat all kind of cheers, like, yeah, woo, I can't wait. So we're looking forward. Well, never know what the future brings. We know as weather forecasters, you never know, but we always can hope.
Voilà. So let's keep positive, and so you have an open and public invitation to come to Darmstadt. That's for sure.
We keep it in mind. Jurek, Thank you very much. Thomas, thank you very much. And of course, Paul, thank you very much for your contribution in this session. Now we're going to have a little technical break again, because we have a last session to do for just half an hour more. So hang on. And it has to do something with this, or this, or this. Something with colors. I love colors. We'll be back at 3:15. See you.